Hello, everybody. Mr. Rubo here. Today we're going to talk about linear inequalities, specifically solving and graphing them. So let's go ahead and just come up with one. So let's say we have the inequality 5 minus 3 sevenths x is greater than or equal to x minus 2. And say the directions say solve and graph. So with inequalities, remember, solving is pretty similar to solving equations. There's a couple exceptions, but for the most part, just do what you normally would do. So with this one, we see this fraction in here, and I know a lot of students don't like fractions. So when you're solving this, if you have one fraction or even a couple fractions, it might be a good idea to multiply by the common denominator to both sides. So I'm going to multiply both sides by 7 just to kind of deal with this fraction. So when I do that, 7 times 5 is 35. 7 times this fraction, the reason why we chose 7 was because that 7 there. So 7 times 3 sevenths is just 3. We have the x still is greater than or equal to 7x minus 14. Okay, and look at that. We have no more fractions. So now let's go ahead and get going. Now, when we're solving these, just like equations, you can move stuff from one side to the other. Doesn't really matter which way you go about it. I personally like to always have the variable on the left side that I'm solving for, but it's up to you. So here, I'm going to go ahead and do that. So I'm going to subtract both 7x from both sides. So I'm going to get 35 minus 10x is greater than or equal to negative 14. Then I'm going to subtract the 35 over. So negative 10x is greater than or equal to, so I'm subtracting it's both negative, or it's the negative, so it's going to be like adding 14 plus 35 is negative 49. Now this is one of the key things not to forget. We're going to end up dividing both sides by a negative. Okay. Depending on how you went about this, you might not have, but because we're dividing by a negative here, we have to flip this sign. So this ends up obviously just being x. Sign is going to flip, so instead of being greater than or equal to, it is now less than or equal to. And then here we try to simplify this if we can. Both have negatives, so those will cancel out, and we're left with 49 over 10, or 4.9. I'm going to leave it as the improper fraction, whatever. So right there, we have solved this linear inequality. Now, to graph it, remember we graph these for linear ones. We're going to graph it on a number line. Since it's just a basic inequality here, we're going to go ahead and just put that tick mark. Depending on your teacher, you may need more. Honestly, I hope you guys understand how number lines work. Left is less and right is more. But that's up to you, or up to your teacher, how much you actually need to fill in. So as far as the graphing part goes, though, because we had this or equal to part, at this spot, we're going to fill in the circle. Okay? And then the reason why I said earlier that I like to have my variable on the left side is because when we read this, it becomes really straightforward on terms of the graph, where I say x is less than or equal to 49 tenths. Well, the less than part would be to the left. The equal to part we already took care of, right? So we're just going to shade this whole side and shade in the arrow, saying that it does go on forever. So if we were to substitute in any number less than 49 tenths, so if we were to substitute in 0, let's say, into the original, we would end up getting a true statement, right? 5, so this would be 0. is greater than or equal to -2. So that would work out. Okay. Um, if you would have solved this with the variable on the right side, you wouldn't have had to deal with this negative, but your answer would have ended up looking pretty similar. Well, you know, technically equivalent. Um, but when you look at this, 49/10 is greater than or equal to x. I feel that a lot of students make a mistake when it's written this way. So if you get an answer like this, it's not wrong. It's totally correct. But as far as graphing goes, it's usually easier to think about it when the x or the variable is on the left side. Okay. So that was kind of a basic one. Let's talk about linear inequalities that contain an or statement. So let's say we have 5x plus 3 is less than or equal to 23, or 44 is less than or equal to 7x minus 5. So here in this case, this would all be one problem, but there's this or statement. Okay, so this or statement means that, especially when we go to graph it, we're going to graph when this is true, when we solve this, whatever this x is, when this is true, and then we're also going to graph when this is true, and because it's an or, both things do not have to be true at the same time, so that's why our answer is going to have two parts to it, usually. So let's go ahead and solve this. I'm going to subtract the 3 from both sides. So we get 20, and then divide by 5. And it's positive, so I don't have to switch the sign. So x is less than or equal to 4. And then on this side, we're going to do similar steps. Add 5. So I get 49 is less than or equal to 7x. Divide by 7. And hey, we get 7 is less than or equal to x. Once again, like I said in the last problem, I don't really like the variable on the right side, so I'm going to go ahead and flip it. And when I flip the x and the 7, I have to make sure I flip that inequality symbol as well, right? So the opening has to still face x because it was facing x in this. All right. So like I was saying before, this is true or this is true for our solution for this inequality. So when it goes to graphing, once again, we got to take our number line, put both things down, so 4 and 7. For this, let's change our colors. Let's go green. X is less than or equal to, so or equal to means putting that filled in circle here, and then less than 4, well, stuff that's less than 4 is to the left. So, all right. And then for this one, we also had an or equal to, so we're filling it in here, and this one was greater than 7, so we're going to go ahead and fill in all the way to this arrow. So here, any answer that is less than 4, less than or equal to 4, or greater than or equal to 7 would be a solution to this inequality, right? So -3 would work for this one, so it's true. 8 would work for this one, so it would be true. But anything between 4 and 7, so let's say 5, if you substitute 5 into either one of these two, you would not get a true statement. So these numbers are not included, hence why they're not shaded. Sometimes with these or statements, you could get where they overlap. So like if this ended up being x is less than or equal to 7, well, you still put the dot here, but then because it's less than, you would just go right over. Okay. So or is when either of these two things are true. Okay. So then you might ask, well, what happens when it says and? Now, I will say usually I don't put and in my inequalities. if it's going to be there. What I will do is I will do what's called a compound inequality. So I will do something like this, and let me change back to black, just so it's consistent. So negative 7 is less than negative 1/2 x plus 3 is less than or equal to 22. Okay, so I could have broken these two inequalities up and done, hey, negative 7 is less than negative 1/2 x plus 3, and negative 1/2 x plus 3 is less than or equal to 22, and solve them separately. And then we have the word and, which means both things have to be true. I like having it as this compound inequality, and you'll see once we get to our answer, I think it makes a little bit more sense visually when you see it this way. So we have a nice little fraction here. If you don't want to deal with the fraction, even with this compound inequality, you could still multiply everything by 2. Okay, so multiply by 2. Oops, pretend that wasn't through the 7. Multiply that by 2 and multiply that by 2. So we get negative 14 is less than negative x plus 6 is less than or equal to 44. Sorry. And so now, to solve the compound inequality, you just have to make sure you do, when you do something to one side, you have to do it to all the sides. Okay. So I'm going to subtract 6. So I'm going to subtract 6 from this one, negative 20. Subtract 6 from the middle, so this cancels out. And subtract 6 from this one, and we get, 38? All right. And so now I deal with this negative. So with the negative, I'm going to divide everything by negative 1. So this becomes 20. This becomes x. This becomes negative 38. But because I did the negative, highlight it here, I'm going to go ahead and switch all of the signs. Okay. Now, this right here, perfectly fine answer. One thing, though, that you want to be careful with is usually with these compound inequalities, the better final answer, the more consistent, or the better looking one, I would say, is when we start with the lowest on the left and go to the highest on the right. So we can see here it says 20 is greater than x, which is greater than or equal to negative 38. I'm going to start with the lowest number first, so I'm actually going to put negative 38 first. Take the sign with the negative 38, flip it. So negative 38 is less than or equal to x. Then flip this one, is less than 20. Reason why I do this is because our number line goes from smallest to greatest, so it would make sense that our answer would also go from smallest to greatest. So at this point, this is going to look a little different than the one with or. We have our number line with our two numbers, 20, okay? And now, this time, because both things have to be true, when we do this, let's start with the 20. X is less than 20. When we do this part, x is less than 20. One, the less than, it's an open circle, and we would shade to the left, right? Okay, but because this part is also has to be true in order for this to be a true statement, x is greater than or equal to negative 38. Greater than or equal to means dot there, and then greater than means I'm shading to the right. Because both things have to be true, I will not shade past this point. Same on this side. So really, I'm looking at this middle section as my solutions, right? And I'm including 38, negative 38, but I'm excluding 20 in this. So if I were to substitute in, let's say 0 up top in the original, so ignore the 2's for now, I substitute in 0, I get 3, and then you can see, oh, negative 7 is less than 3 is less than or equal to 22. That's a true statement. If I substitute in 20, though, I would get, oh, negative 20, or I'm sorry, negative 10 plus 3, so it'd be negative 7. Well, negative 7 is not less than negative 7, so that wouldn't be true. So that's why that's not included. Okay? So all of our solutions lie between negative 38 and 20, including negative 38, not including 20. All right, hopefully you enjoyed the video, and have a nice day.